and welcome to this video that is going to talk about solving quadratics by completing the square. I'm going to do two examples. This video might become lengthy, so if you notice here, I've put a kind of a table of contents of times of where to look in the video for this. The two types of examples that we're going to work on are examples where the lead coefficient is 1 and examples where the lead coefficient is not 1. And just so you know what we mean by the lead coefficient, if you look at the degree term, which is the quadratic term, here in this first example, the coefficient of x squared is 1. Okay? And then here in our second example, where we look at the quadratic term, its coefficient is 3. So down here, these problems are a little bit harder. So if you feel comfortable doing this one, maybe take a look at the other example. Okay? So let's get cracking. It's a long list of steps here in this process, only because I've tried to write them out as specifically as possible. Once you get good at this, I think it doesn't feel like a 10-step process. So please solve. X squared minus 8x plus 1 equals negative 19. We could go to our calculator and use the root finder, but we're asked to demonstrate it by hand method here, so we will do so. We will look at completing the square, and let's get going. Steps. Step 1, isolate the constants to the right side of the equation. Well, the constants are the non-variable terms, and if you notice, I have negative 19 on the right, but not this value of 1. So I will, in fact, just quickly subtract 1 from both sides. Okay, and that will give me x squared minus 8x is equal to negative 20. And that was step 1. Okay, now it says if the lead coefficient is not 1, factor out the coefficient from the first two terms. Well, you notice here the lead coefficient is 1. So I can, in fact, just skip this step. Okay? Now it says set up a place to add a third term, which makes sense because a perfect square trinomial is, in fact, going to be 3 terms. So we are going to write x squared minus 8x plus blank for this third term is equal to negative 20 plus blank. If you notice, why do I set up the blank on both sides? Because you will be asked to later add the result to both sides to preserve equality. We're going to add something to the left, we're going to have to add it to the right. Okay? So here we go here, where it says step 4, cut the coefficient of the linear term in half mentally. The linear term is the one where the exponent for x is 1. So if I cut that in half mentally, I get negative 4. And in step 5, it says to square it mentally. So I'll square negative 4 and get 16. And then it says add the result to both sides in a way that preserves equality. Okay? Well, in this example, I'm just going to add 16 here. So if I've added 16 on the left, I'm going to add 16 on the right, which does not seem too hard. Okay? In the other example later in the video, there is a trick there with those. Again, if you're curious, those are the ones where the coefficient is not 1. Okay, so we will continue on to step 7, where it says factor the perfect square trinomial, which I've created here. So I will get x minus 4 squared equals negative 20 plus 16 is negative 4. Then it says here to isolate the square. Well, my square here is x minus 4, and it is isolated. Again, that is a step that you will need to do in examples where a is not 1. So now we'll take a look at square rooting both sides. Okay, so we're going to square root both sides and be left with x minus 4 equals plus or minus the square root of negative 4. Very important that you remember when you're square rooting both sides that you get a plus or minus. So if you want to put an asterisk here and remember, plus or minus. Okay? Well, in this example, I have an imaginary number, so I'll just go to margin to take a look at simplifying the square root of negative 4, which becomes 1 times 4, which becomes 2i. Again, the opposite of a perfect square just becomes the root you would expect with the the imaginary number. So I'll continue to rewrite that and say x minus 4 equals plus or minus 2i. And then in my last step where it says to isolate x, I'll do so by adding 4 to both sides. And that will just give me x equals 4 plus or minus 2i. Now, if you wanted to be able to check that on your calculator, the only thing you would need to do is make sure that you put your calculator in imaginary mode, because we've got an imaginary answer here. So scrolling down by hitting mode, over to a plus bi, hitting enter, going to your home window, and then we'll store that value of 4 plus 2i, 4 plus 2 second decimal point. Okay, store x, and then the only thing I need to be able to do is type the original problem, which is x squared minus 8x plus 1, x squared minus 8x plus 1, and hoping we in fact get a result of negative 19, which we do in fact get in the problem. Now I only checked the 4 plus 2 minus I result. If you check the 4 minus 2i result similarly, you would get the same thing. Okie dokie, so I'm going to move to the next example now. If you've fast forwarded to this part by taking a look at the table of contents and said, I want to start on a harder problem, I have great respect for that, and I will in fact take you through this problem, which is an example where the lead coefficient is not 1. Okay, these are a little bit harder. Okay, so we will probably tend to work all 10 of these steps. Okay, we will start with isolating the constants to the right side of the equation. So I'm in fact going to get rid of this plus 10 by just subtracting 10 from both sides and getting 3x squared minus 12x equals negative 10. Okay? Now, it says here, if the lead coefficient is not 1, and it in fact is not, it's 3. So I will do this step. Factor out the coefficient from the first two terms. So I'm going to factor out the 3, not the 3x, even though this has a GCF of 3x. I'm just going to factor out the coefficient, which is going to give me 3 times the quantity, x squared, minus 4x equals negative 10. Okay? So that was step 2. I'll try and color code this so you can follow it. Now it says to set up a place for the third term, so I can make a complete the square problem. So what's that going to look like? It's going to look like 3 times the quantity, x squared minus 4x, plus some third term, is equal to negative 10, plus some other term that I'll have to add to make sure later in the problem that I am adding a result to both sides to preserve equality. Okay, so now some mental steps. Cut the coefficient of the linear term in half. The linear term is negative 4. Cutting that in half gives me negative 2 mentally. Then it says to square it. So negative 2 squared will give me 4. And then it says add the result to both sides in a way that preserves equality. Okay? And I will do that in green for now. Pay attention, because this is definitely going to be a trick. I said I was going to add 4 to both sides. Again, when I cut the linear term in half, I get negative 2. When I square it, I get 4. Well, when I add 4 here, this wording kicks in that says add the result to both sides in a way that preserves equality. Well, here you see I wrote 4, but I in fact didn't really add 4. So I can't really add 4 here. Now you're saying that makes no sense. That looked totally right. What's wrong about it? I'll say it again. You wrote 4 here, but if you look carefully, you really added 12 because you added 3 times 4. So writing the 4 was important for creating the perfect square trinomial, but balancing the equation means you in fact are going to have to add 12. Okay? So that's definitely a little bit of a trick there. Okay? So now I'm going to factor the perfect square trinomials. That's going to be 3 times x minus 2 squared is equal to 12 minus 10 is 2. And now it says to isolate the square. Well, my square is this right here, so you notice I'm going to need to undo the multiplication by 3. So I will, in fact, divide by 3, and that is going to give me x minus 2 squared equals 2/3. And now, as I'm kind of running out of colors here, I'm going to square root both sides. So let me go back to blue here. It's far enough away from where we started. I'll square root both sides. Don't forget to do that plus minus. So I'm going to square root both sides and wind up with x minus 2 equals plus or minus the square root of 2/3. Okay, now for those of you that have seen how to rationalize the denominator here, there's a little more work to do with that, depending on how your teacher's going to grade it. The square root of 2/3 is also the square root of 2 over the square root of 3. And you may not have a denominator that has a radical, so if you multiply by root 3 over root 3, which is really in fact 1, which is kind of a great conversion trick because you're not changing this number right here if you're in fact multiplying by 1, and that is going to give you, if you notice, root 6 when you multiply across the top, and root 9 on bottom, which is just 3. So I'll continue on here. X minus 2 equals plus or minus root 6 over 3. And then the last step here says to isolate x, which I'll do by adding 2 to both sides. And then that is going to give me x equals 2 plus or minus root 6 divided by 3. This can be checked on your calculator quite readily by doing 2 plus second square root of 6, closed off. Careful, you got to make sure you close it off there. Divided by 3. Okay, checking to see if that's right. Store x, right? Then I will enter the original equation, which is 3x squared minus 12x. And I believe it was plus 10. And I am very much looking forward to this being 0. And it is. And again, if I went second enter to go back up to where I entered that answer, I could change the plus to a minus with relative ease. And then second enter, showing that that fits the expression as well. Okay, so I hope this is a process that benefited you. I tried to present this video in a way where you had an easy example and a hard example. Okay, again, the easier examples are the ones where the lead coefficient in the quadratic term is 1. The harder examples is where it's in fact not 1. I tried to make this example interesting if you did in fact watch it by getting an imaginary number, completely a legitimate possibility. So I hope this is bringing your skill up with complete the square. Feel free to watch again and practice, 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 practice.